By this point, you should have had quite a bit of practice with getting out your notebook, writing down the problem numbers or the learning objective, and starting a page so that you're ready for when you're tested on this stuff. But you also should have had a bunch of practice turning condensed structures into line angle or skeletal structures. So we want to answer this question. Are molecules constitutional isomers, identical molecules, or neither? So, refresher on what that means. You have read it or seen it in a video. Isomers are things with the same formula, but are put together differently in some way. And constitutional isomers means that to switch from one to another, you'd have to actually break a bond and make a new bond in a different place. So, we're going to look at this. There are a few things you can do. First, I would do everything in a skeletal structure. That's the easiest way to see if things are the same. So we've got two CH3s, so they're sticking out on the ends, both connected to this C. So I'm going to put two CH3s connected to a C, CH. Then I've got another CH, and it has a CH3, so that's got to be sticking out from it. Can't be in a chain with it. Two CH2s, 1, 2, and then a CH3. All right. The others I've already got as line angle structures. So I'll write some suggestions. Convert everything to line angle structures. That might be enough for you to tell if molecules are the same or not. We haven't talked a lot about numbering the main chain. You've done it, you may have done it a little, but since we haven't been naming molecules, you might not have much experience with this, but let's do that. I'm going to pick a place and start numbering it. And, even if you get the numbering wrong, it doesn't really matter as long as you have some consistency. So I've got this fork here. I'm going to take one end of it and call it 1, and then go along the longest chain. And I'm going to do that with each of these molecules. This has a fork as well. This one doesn't have a fork, but I'll pick an end and start numbering it. This has a fork over here. So no matter which way the chain goes, I number the longest chain. That allows me to identify what we'll call side chains. So let me highlight some side chains. All right. For a molecule to be the same, it's going to need to have the same main chain, and every one of these has a 6-carbon alkane as its main chain. And then the side chains need to be the same. And you'll notice every one of these has 2 methyl groups as side chains. So far, we can tell the formula's the same. All of these are either identical or constitutional isomers. All of the molecules on this page. So they're identical now if the numbering for the methyl groups is the same. So this one here, I go to 2, that's 2-methyl. And this one would be 3-methyl. I can go here, 2-methyl, 3-methyl, here, 2-methyl, 3-methyl. Go up to this one, 2-methyl, 3-methyl. Then I go to this one, and it's 3-methyl and 4-methyl. So all of these, this, and this, these 4 are identical. And 1 is a constitutional isomer. This one here. So what did I do? I converted everything to a line angle. I numbered the main chain. I identified and compared side chains. And you can do all that without knowing all of the perfect naming rules. You just have to number things in a consistent way. And the way I chose is the standard way, where you start where the most branches are to give the lowest possible numbers. But if you messed that up, it wouldn't really matter for telling if things are identical or isomers. You just have to be consistent in how you do it on that problem.